Well, good morning, everyone. Welcome to this session about Microsoft and WebAssembly, .NET and WebAssembly. I'm Jerome Laban. I'm from Montreal, Canada. I'm the CTO of the open source project Uno platform, and I'm going to be talking to you about WebAssembly using .NET and the journey that we had to go through to get that working using WebAssembly. So I hope that during this session you're going to learn that WebAssembly is a kind of an amazing technology, and that you can start using it today, and that you're going to try experimenting with it. So to start, what's WebAssembly? Well, WebAssembly is low-level bytecode for the web. By bytecode, we say something that runs on a kind of a virtual machine or a conceptual machine. It doesn't exist, so that means that it has to be implemented by an environment, and most commonly these days it's web browsers. It has a binary format, so it's the .wasm format, the file format. So if you go to a website that has WebAssembly in it, you're going to see WASM files coming in through the wire. It also has a textual representation that you can see here. I'm not going to go dive into the details of the format because it's kind of a, for bare people, something like that's very complicated to read. It's not exactly assembly, but it's pretty complex to read. I'm going to show you a little bit of a demo afterwards so you can see a little bit of what it is, but afterwards it's going to be mostly C# and .NET. What's interesting about WebAssembly is that it's available in most web browsers. When I say most, it's IE is not supported anymore because it just stops at JavaScript and some versions of it. But for the rest, mobile included, it works there. I mean, you can take a WebAssembly file, put it there, and it's going to run the same on all platforms. There are some caveats there that I'm going to talk about later on, but basically it runs. And it's aimed at being a compilation target for many languages. So you got C++, C#, Java, Rust, Go, and many others. Python has been added recently, and they're having a very large set of features there that you can run inside of your browser. And what's the interesting part there is that as an end user or a developer, you're not going to be targeting WebAssembly as a language. You're going to be targeting it as a platform or CPU architecture, as the same way that in Visual Studio, you're going to select x86 or x64 ARM for that matter. So it's going to be WebAssembly as a target. And what makes WebAssembly interesting is that the performance characteristics of it are about learning from the past and learning about JavaScript, how the JavaScript works, and especially about the fact that JavaScript is running on two cores mainly. The UI itself, or the JavaScript code itself, run only on one thread. And it's very difficult for a browser to optimize for that. It has to download the whole file, parse it, then finish the parsing, then tries to compile it JIT. There are tricky things like tiered compilations that improve the performance, but it's not, I mean, it still is a problem. So if you want to create or have some very fast-performing code using JavaScript, you got to know what you're doing, and it's still single-threaded. So there's web workers, but it's still not the same. For WebAssembly, it's a lot different. There's a lot of things that have been thought through, and the format itself is able to be JITted and compiled directly, decoded and compiled and executed for now on single thread, but parsed on multiple threads at once. So the more threads and cores you have on your system, the faster it will go. And it's not something that will come soon for JavaScript. So that's one of the key aspects about WebAssembly. And that's one of the things that most talks about WebAssembly are going to talk about, the fact that you can get close to the metal in terms of performance because WebAssembly is a very simple language with not that many instructions. Another key aspect is security. WebAssembly runs in the same sandbox as JavaScript, so that means that you cannot do anything that JavaScript is not able to do. And it's also installed by default on web browsers. It used to be behind feature flags, but not anymore since the past year or so. So that means that it's not like Silverlight or Java Applets or XBAPs, if you remember those. So it's something that's completely secure, or at least as secure as it can be for JavaScript. So I'm gonna be showing you a bit of a demo about WebAssembly and how we can do something about executing a little bit of C code. And that's probably the last part of C code that I'm going to show you in the demo. So I'm going to create a C project using a website that's called WebAssembly Studio. It allows for testing and executing inside of a browser a bit of C code and execute it locally. What I'm going to do is just create an empty C project. And you're going to see here that when I build that project and run it, in the output, you're going to see that the result of the main project here is probably a bit too small. Let me do that. So the main returns 42. So you're going to get that result out in that window here. So the interesting part about WebAssembly is that it reuses a lot of existing technology that have been developed over the years. So that means that LLVM, for instance, if those of you know about it, is an optimizing compiler. That means lots of those optimizations can be baked in. And I'm going to show you one of those optimizations. So if I add a method here that does a simple add, and I call that add inside of the main method at the top, you'll see that the compiler is already doing optimization. So if I build it again, and I run it, I see 3. So simple one, very simple code. Just so you know, the compilation is done on the outside, so it's done on a server, and the WASM file comes back and is executed locally. And then what we can do is go see what's inside the WASM file. So the interesting part here is that you're going to see one single method that's exported. It's called the main method, and you're going to see that that method takes an input as a result as an int32 and returns a constant of 3. And the reason for that is that the compiler has optimized that method call as it would and inline those calls as in any C project that you will build normally. So that's interesting, but that means also that that method that I wrote, if I want to use it from JavaScript, the main I can use from JavaScript because it's exported. But if I want to use my add method from JavaScript, then I need to tag it to say that I can use it, that I want to use it. So we're going to go back in that C method, and I'm going to take the WASM export directive that's at the top and add it on my method. So now if you ever use that site, don't forget to save the file because it doesn't save on build, which is unusual. So now, well, let's say I'm going to put something else so we can see what's happening. So now the build is complete. I run it again. I have a new result. Now, if I go back to the WASM file, what I'm going to see is that now I still have the 5 that's been executed because the method has still been in line and because of the constants that are on the method call. But the method add now has been exposed as something that I can use from WebAssembly. So I'm not going to show you how to do that because it's not that very useful there. But the idea is that you can expose methods as exports as a DLL, for instance, is the same way of thinking. Expose a method, a C method, and call that from any other WebAssembly module or from JavaScript. So that gives you a rough idea of that. And for the rest, I mean, it looks like assembly. And you're going to see directives for managing the memory, the maximum memory of the WebAssembly file, things like that. Inside of a WebAssembly module, the memory is linear. So when you instantiate a memory module, you're going to get a very large buffer that you can add memory to when you do some mallocs and things like that. But it's all managed by the runtime. So if when we're going to go to .NET, you're going to see that all of this just disappears away, and you don't need to think about it. So continuing on to to the use cases. So that's where it gets interesting. So I've shown you a simple method to call, and well, that's fine. It's just simple C code. But people have been doing very interesting thing about it. And AutoCAD made a demo of their whole suite of AutoCAD tooling that runs in the browser. Unity is also doing things like this. Their engine runs in WebAssembly. They built it for their C code or C++ code at the time, and now running it. There's Emacs as well that runs in the browser if you use it. And there's another one that's very interesting. It's Windows 2000. And there's that guy. There's that guy that is an expert on doing virtual machines. And he said, well, I know how to make a virtual machine. That's C code. It emulates x86. Why not take a full operating system and just put it into the browser? And that's what he did. So now you have in the browser a full Windows 2000 running there. And the only thing that makes sense to do on that kind of a machine is just do something like this. Oh. I mean, it has to be this. So that gives you an idea of the kind of things that can run inside of a browser. I mean, it's a full operating system. It even has Firefox. That means that you can get WebAssembly in there and then run Windows 2000 inside of it. It goes far. It goes far. So that gives you an idea of the things that you can get there. Lots of other operating system can run. It's a standard emulation. It even has, I think, there's no local storage access, so it has to emulate all that. And it's a part about mscripting that we're going to talk about a bit later. But you get the idea. It can go really far. So this is known as canvas rendering. The content of the virtual machine is drawn as pixels directly inside of an HTML canvas. We're going to dive into this a little bit later, so you get an idea of what that is. So there's one thing about WebAssembly that the whole community is kind of agreeing on, is that WebAssembly is neither web nor assembly. And why is that? Is because it's a bytecode that can run anywhere, pretty much. If you look at the specs for WebAssembly, it doesn't say much about web browsers. And it's not an assembly language as well. If you've done assembly, you're going to see that there's not directives like this. I mean, there's no memory management specifically in that. I mean, if you want to do a malloc and using assembly language, you're going to do completely different things. And that's not what WebAssembly is. So that's why we're saying it's neither web nor assembly. And the interesting part is that people are using it to do very interesting things. And notably, Ethereum, they have some kind of a derivative of WebAssembly that they use to run their smart contracts. It's a cryptocurrency that allows to run untrusted code on many nodes of the network. And it makes total sense, because of the security model of WebAssembly, to run untrusted code there. You got Cloudflare also that's very interesting. What they're doing is they're trying to get Node out of their edge network to run untrusted code there. So your code that can run on the edge to make customizations on whatever they provide as the service. But the idea is that JavaScript is a problem, and especially, I think, if I remember correctly, when they started doing experiments about running WebAssembly, the default about running Node in terms of memory consumptions was about, let's say, 10 megabytes of startup memory, as where for running a WebAssembly, it's in the kilobytes. So it makes a lot of difference because you can be very close to the metal and have very fast performance there. There are others like WebAssembly for .NET. That one's very interesting as well. It's about taking WebAssembly, compiling it to IL, or transpiling it to IL, and then executing it inside of a .NET environment. So interestingly, things like taking SQLite, compiling it to WebAssembly, then transpiling it to IL, and then execute it as a DLL. Things like that. So it goes far, and it's simple enough of a language to be able to be kind of a segue to something else. I'm not going to talk right now about Nebula, but it's basically an environment that, if I remember correctly, is developing Go live as well. And Lucette, I'm going to talk about this one just after. And it's about what is called WASI, the WebAssembly System Interface. The biggest problem right now about WebAssembly is the fact that it doesn't do anything. What I mean by that is that it doesn't provide system access. It doesn't provide anything to go with a networking. It has to go through something else. And in that stack, for now, when you're in the browser and you're compiling WebAssembly, if you want to access the network or write on the file, you have to go through mscripten. Mscripten is kind of a glue that allows you to, when you're in a C or a C++ program, when you're opening a file, to emulate the fact that you're opening a file. But it's not opening a file, a real file. It's opening something that's in memory that looks like a file, but it has to be emulated. And the biggest problem with that is, well, if you want to make a program that's outside of a browser, you need to be able to provide system access. So file system, thread, timers, random number generation, sockets or anything like that. And the industry has recognized the fact that WebAssembly is able to go way farther than that. And they started to introduce that interface, and that means that it has the potential to change a lot of things. And one thing that struck me is the fact that the founder of Docker, Solomon Hykes, told on Twitter that if that specification in WebAssembly had been released or made a few years ago, Docker would not be the same, because of the security environment, the containerization that it allows, the fact that you can completely isolate everything using WebAssembly, it would have changed quite a few things. So it may still change quite a bit, especially around the use of Node. I mean, Node is still using JavaScript, and if you were able to use any language and run that on any platform you want, that would be very interesting. And that's what they're trying to do with WASI. So look for that one. It may make a lot of noise in the future. In terms of architecture, basically you got your language at the top, so the things that you manipulate directly. Then they get compiled to WebAssembly, and then WebAssembly as itself, because it doesn't do anything, it has to go through JavaScript to do something. So for instance, if I want to, let's say, display something on the page, if I want to open a file, if I want to go on the web, then I need to go through JavaScript at the moment. So that means that most of the WebAssembly applications are going to be doing some JavaScript at some point. It has its cost, but for now, it's the only thing that we can do. Maybe with WASI and some other specs that are coming in for WebAssembly, it will change, but that's not the case yet. So that means that when you're in JavaScript, well, you can do everything. So manipulate the DOM, you can use all the W3C APIs such as USB, so web USB, web Bluetooth, or camera access or anything like that. That means that everything's accessible from WebAssembly, but you still have to go through WebAssembly, through JavaScript first. And the other thing that's interesting is that WebAssembly, because it's so close to the metal, it goes directly to the CPU, so that you get the full performance there. And it's actually going to go farther down the road with the new features that they're going to add to WebAssembly, such as threads or SceneD. So now we're going to move on to .NET. And .NET has been interesting because WebAssembly was announced in 2015, the spec itself. It got tech previews in browsers a bit later. And then the MVP got finished, a small set of features that would make sense to execute simple C code or C++ code at the time in 2017. And then the major browsers implemented those, and they started to hide that behind feature flags. That means you could try your WebAssembly code, but you could not use that in production. And then after, all browsers just moved that away and implemented that properly, got it out of the feature flags, and then Miguel Icaza at the time, so in January 2018, started talking about, it's interesting, WebAssembly, maybe it's the mono runtimes in C, maybe you should compile it to WebAssembly and see what happens. And there were 2 tracks about testing out Mono for WebAssembly. At the time, I looked at the article. I said, well, that's interesting, WebAssembly. Well, that's new, but it doesn't seem to do many things. But then a few months later, a few things happened. The GC started working. The tooling starting to get better, and we started to throw things at it. Like, for instance, small program, getting reflection working. Then we say, why not throw reactive extensions to it? Started working as well. We started putting things like JSON.NET or many complex things, and all that started working. So it got us interested, to say the least. It wasn't expected to be able to run that many things inside of WebAssembly. So we're talking about running everything locally on the browser using .NET, full .NET. And then a few other things happened afterwards, like AOT support. So AOT is about compiling directly to WebAssembly, because the first mode that happened was the interpreter mode, which is just reading IL instructions one by one and not actually executing WebAssembly. And then a few other things like mixed mode support that I'm going to talk about later on. So the story was very interesting because overnight, 1 month to the other, it just changed completely, and the feature set improved significantly. So if we're talking about the structure of all this, basically it's C#, F# at the top. That's the two languages that are supported the best at the moment. You got the .NET Intermediate Language right underneath. Then the Mono Runtime, that's C code compiled to WebAssembly. So this one is really WebAssembly, not as always. So when we're using the interpreter mode, the IL is not compiled to WebAssembly first. It has to go through the runtime and then be interpreted one by one. And then the same stack goes after. You got WebAssembly that uses mscripting for the emulation of the file system, anything that goes with timers and things like that. And then you get JavaScript underneath. So the problem with that is, and it's still the case actually, is that the tool chain itself is, let's say, for the lack of a better word, bare bone. There's not much that you can do. The documentation is scarce, and there's one tool that you can use on the command line that's, you have to know what you're doing, lots of parameters, and we said, well, why not do something to help about that? And there was Frank Kruger at the time that works on the OE framework that made a little bit of a thing that takes MS-Build and uses that to package WebAssembly applications for his project. So we decided to take that and start something that would allow us to make a very simple program without any UI, kind of a console-like program, if you will, and do the project that's called the Uno.Wasm.Bootstrap NuGet package. So that package is about being a simple NuGet package that you can add to a .NET Standard project, and take that, make it a binary and a simple website that you can just expose on any web browser. You just make a web server and expose that. You navigate to it, and it's going to be running the WebAssembly directly there. And it's easy to deploy on Azure websites as well, Azure Web Apps. So it's about right-click, publish, and then go to the web. So what I'm going to do is show you what that means. So here I have a Visual Studio. I'm going to create a simple .NET Standard 2 project. And for that project, what I'm going to do is take a snippet of the code that you can find on the open source project itself. And that project is about giving you the default configuration there. Probably in the future, we're going to create something like .NET New, so you can create your project directly, so you don't have to go through the fiddling about the project. But basically, it's a .NET project that has some things like the debugging enabled, and has a package reference to the Bootstrap, and something that enables the ability to run directly from Visual Studio. So it seems there's a bug with NuGet, so I'm going to have to unload the project and reload it. So that's NuGet restores the content properly. And now what I'm going to do is that I'm going to use something that most of you don't use, which is the snippet that's called SVM that makes a static void main. And then make a write line to say hello build. And right after that, I just press Control F5, and then I run that. It's going to build the website. It's going to do a few things to call Mono and the toolchain for Mono. And what is going to happen is a white page. And that white page is actually because my app is doing nothing. It's just doing a write line. So what I can do is go inside of the debugger and go to the console. And now I can see that I have my hello build that happens to be here. Okay? So that's a very simple one. I mean, I didn't do anything else. It's just the package that does everything, creates packages, runs a few steps to make it easier. But basically, that's what it is. So now, that's fine. I mean, that's nice. I've got a few things that are there. Just to show you what that means by downloading something from the network, I'm going to refresh the page and give you an idea of what goes through the network. So I've got a few JS files. Then I've got the Mono-Wasm. So that's the actual runtime. It's a file that's about 1.6 megabytes that gets downloaded there. And then you got what we have what the bootstrapping tooling NuGet package is doing. It's transforming the DLLs into .clr files. And the reason for that is that most corporate network firewalls treat DLLs as viruses. So we rename those files so that it goes through. It doesn't always work because sometimes there's deep inspections of files, so it still doesn't work. But that's the kind of thing to know about when you're testing with this. So that's the reason for the .clr files. So you're going to see a few things like that. You're going to see PDB files. So you get the symbols for that. So that means that we can do interesting other things. And by interesting other things, I'm talking about things like this. So I'm going to be adding a very small loop. I'm going to be publishing that again. And I'm going to do something very interesting. So I'm going to go back here, and then I'm going to go in sources. And in sources, let's refresh that. Oh, well, demo gods are here. All right, let's try again. Okay, no, it still doesn't work. Okay, I'm going to go through. The idea is that you should be able to see the C# files there. It's too bad that it's not working here. And just try another thing. So a few things that you can know is that it's .NET running underneath. So you can debug that by removing the .NET runtimes that are running behind, and then start again. So it may start again. That's a few things that you can manage and to restart your debugging experience. So it's not working for now. We can see that there's WASM files there, but the idea is that you can stop and dive into. So one of the features that I was able to add for debugging WebAssembly files is the ability to dive through. And one feature that Microsoft has been adding recently is the source link support. And with the debugging tooling that is in Visual Studio, you can go through and dive into the .NET source tree directly. So inside of the browser, you can step into, let's say, console.writeline, for instance. I'm going to try again, because that's still, it should be a good demo. No, still not. OK. Well, you can see that in the runtime, you're going to see that there's my loop that run here, and that you can see that it actually ran. There's a few things that can be done as well, but the idea is that because the runtime and all that is open source, you can go and manipulate itself and manipulate the debugger and the runtime. So you can make very, very simple modifications to runtime. That's why we are able to make all this progress very quickly by adding directly the modifications there. So if you go a bit further, the runtime's execution modes are interesting for Mono. You got the interpreter mode, That is slow in execution because it interprets the instructions one by one. It has a short build time because it does nothing. I mean, it takes the Mono-Wasm runtime, just pushed to the browser, and that's pretty much it. There's debugger support when it works. That's one of the things that is a bit complicated there. There's another mode that's called the full AOT compilation. And what that mode is able to do is that it takes your IL and compiles it down to WebAssembly. The problem with that is that it creates very large binaries. And when I'm talking very large, I'm talking tens of megabytes. So let's say for an assembly that's, let's say, 1 megabyte, you may have 10 megabytes of WebAssembly that's generated. And there are multiple reasons for that. Two are the fact that Mscripton is using a very old artifact that's called ASM.js. And it has to go through multiple steps to do optimization there, but they're not as efficient as they would. And there's the LLVM 7 that has added improvements there for improving the code size, the compilation time as well. And so when I'm talking long build times, I'm talking for a medium application, we're talking about 7 to 10 minutes. So it's quite large. It's very similar to what Xamarin iOS is showing off in terms of build times for building on devices when you're enabling all the optimizations there. It also requires the use of the IL linker. So the IL linker is about removing code that you're not using. Because the more code you try to build for AOT, then the bigger your assembly gets and the slower your build gets. So you may still want to do that. The caveat there is that everything that uses reflection can be tricky to work with. So you may want to mark your files there. The Uno.Bootstrapper provides a linker configuration file. So if you're doing reflection and you don't want your classes to go away, that's something that you can do. Another thing that's interesting with AOT is that you can use the profiling inside of the browser. So that means that if you have the profiling tools there, if you open a profiling sessions, then you're going to see all your stack that are in .NET. In the same way that if you're on iOS, you can use instruments to profile some code there. And because it's IL compiled down to C, that means all the methods that are available there are visible inside of the stack traces of the profiler for each browsers. For now, the profiling works best in Chrome. That's where you're going to find the best tooling there for profiling. So the story evolves quite a bit in that sense. And there's the last mode, which is about being in between the two. The problem with interpreter is that it's slow, but it's making small binaries. AOT is fast in execution, but makes very large binaries. So the Mono team said, well, why not take both of those and make something that's in between? And the idea is that you can have something like what is called profile-guided optimization. So basically, you're going to run your application once with the profiler enabled there. And it's going to analyze what methods are being called when you're executing your code using the interpreter. And then you're going to pass that file, the profiler file, to the optimizer. And then it's going to AOT parts of your application to make them fast, but not the others. So for instance, if you're, let's say, doing something during the initialization of your application, those parts are going to be optimized. But if you're doing something like open an about window, that is not going to be optimized. And if it takes half a second more, it may not be a big deal. So that's kind of optimization that can be done there. And there's also the Safari support. Safari support is a big problem because they have very low limits in terms of WASM size. So you cannot go over 10 megabytes for a WASM file. So that means that for a large application that they're too large, it doesn't work. It just begs out saying out of memory. So it's a constraint that makes a mixed interpreter AOT mode very interesting. The Mono-Wasm Debugger only works in Chrome. And the reason for that is that it uses the Chrome DevTools. So for now, the Xamarin team the Mono team is working on that. And they're trying to optimize that and make it available for other browsers. So since now the new Edge is using Chrome, it may work as well there. So it's going to leave Safari and Firefox to support. It's doing fancy tricks to communicate with the debugger instead of a proxy. That's probably what that didn't work in my demo. Sometimes the WebSockets don't work properly. So it may be something that has to do with the configuration here or something like that. So that's something that I have to debug. And there's also one new thing. And that's something that actually I had a pull request that passed a few days ago. It's the ability to do pinvoke. And pinvoke is one thing that's very important when you want to reuse your binaries. And the objective for me was to be able to run SQLite and Skia. So Skia is a library that allows to do pixel and let's say image manipulation. Chrome is using it to draw itself. So that's the kind of library that we're talking about. We're talking about 600 files of C++. So the Skia team made a WebAssembly module out of it. We had to modify it to be able to run on the side. But the idea is that you can take that, make it into a WebAssembly module, and then load it on the side with Mono. And then Mono is able to call the methods that are on the other WebAssembly module as if they were DLL exports. So that means that it's very easy to work from one module to another. That's something that didn't work a few months ago, and it makes a dramatic change because when it was possible to call other WebAssembly modules previously, but the problem with those is that you have to go through JavaScript first, and it makes it very, very slow. And it is also the fact that if you have two WebAssembly modules loaded at the same time, they don't share the same memory if you don't do pinvoke that way. So that means that you have to go through very complex hoops like copying memory around and things like that. So not very interesting to work with. It also requires a specific configuration for Mono that's a bit larger. It's a name script and limitation, and it needs to have shared code and things like that. So not to go into too much detail there, but just so you know, pinvoke works there, and it's pretty amazing. So what about the UI? I mean, if I want to show something to the user, it's nice to have console.writeline, but it's not enough. So let's do another demo to show you that. So what I'm going to do is just expand the demo that I had before, but I'm going to add a few files. So I told you that I can run JavaScript from the C#. So what I'm doing is just basically adding a JavaScript file here that contains a few things like creating an element from the document, so the root document, adding a text node, adding that to the body, and trying to display that. So now I'm going to add a few other pieces of code that allow for that to work. So the first one is about giving the ability for my library to call into JavaScript. It's about internal calls to Mono. So it's about invoking JS, JavaScript, and things like that. It's internal stuff that you don't need to work with most of the time, but if you do, that's the way to do it. It's included in the Mono SDK. And I'm also going to add a single line that calls into JavaScript from my project here. So I'm going to replace all that, and I'm going to add the no quick actions. OK, didn't want to. So the runtime's here, so it's about using WebAssembly here. So I'm going to build it again, and hopefully it's going to show something for us. So hello build. So it's really about invoking JavaScript from your C# code. So I mean, it's kind of clunky. You're executing something from your from your C# code there, but you may want to, if you're calling JavaScript only APIs, that's the only way to do. But if you want to go through and call some C code, you may want to do dynamic linking instead. So you got to go both ways. You can get return values as well. So the problem here is that it takes strings, and strings, I mean, are a problem. They're slow. That means it has to go through eval. So gets difficult. There's a few things that we're doing to improve that, like passing memory pointers. Memory marshalling works there as well, so you can do global alloc and things like that. Marshal to pointer, structure to pointer, things like that. So that's how deep you can go when doing interop with JavaScript. So having seen that, I mean, it's interesting to modify the UI, but there are multiple ways to do so. So the first one is what Blazor is doing. Blazor is another framework that's done by Microsoft that runs on top of Mono as well. And they're basically using Razor pages to render content. So that means that you're basically writing something like this, and then the output of this is HTML. So you're still manipulating HTML. And I mean, that's fine. I mean, it's what people have been doing for a very long time. It's a pretty cool framework. I encourage you to go look at it. It's very nice. The other way to do so is using Canvas pixel rendering. The demo that's on the side is something that the Qt folks have been doing. And they're basically taking the rendering engine, and they're drawing everything by the pixel. It's the same way that the demo that I showed you earlier about Windows 2000 that draws the whole operating system. And the only way to do so is just create a memory buffer, frame buffer, and just pass it to the canvas one by one. So every frame is a new canvas. Not new canvas, a new image that you send to the canvas. So it can be fast, can be slow. There's another method that's close to it is using OpenGL. Some are using it. Skia is using it sometimes. There's a mode for that, so you can make very fast rendering engines using this. And there's another way to do it. It's what we call HTML generation. And that's where, at the Uno platforms, we went and pushed that, what we've been doing with XAML for the past few years. And we're taking XAML and we're pushing it to basically HTML. So where, let's say, the stack panel becomes a div, a text block becomes AP, so a paragraph. So we're writing text that way. And we're invoking, in the same way that I've shown you using the small JavaScript file, bigger files, obviously, but we're doing the same thing at a higher pace. So I'm talking a bit about the Uno platform. It's an open source project that uses, that we open sourced last year at Build. It's free to use, and it shares XAML on C#, iOS, and Android. Shares XAML and C# on iOS, Android, and WebAssembly. And that's the interesting part. It's about getting to WebAssembly. It implements the API service of UWP, so that means that you can share everything and push it to WebAssembly from a Windows app. And it has many of the UI APIs, so that means that you don't need to learn about divs, and if you don't like JavaScript, you can do everything in C#. That's one of the cool part. There's also non-UI things like getting access to geolocations and sensors, and it's also about reusing libraries. So any .NET standard library can run, and it can also run on the web. That's another interesting part. And if we look a little bit about the structure of the Uno platform, it's about Windows doesn't do anything about Uno. On the web, it's about, your code is shared across all platforms. It's the same exact code. On the web, it's using Mono directly. On iOS and Android, it's using Xamarin, what we call Xamarin Classic, which is the bare bindings that go through to Objective-C on the one side and goes to Java on the other side. What that means as well is that when we take a text block, it has to be translated to something else. So it can be translated to a UI label, to a text view, or to a paragraph, depending on the platform. And same thing for platform API. So if you want to save a setting, like the username of your username that you're entering when you're logging onto the application, can go to, so it's setting storage for the UWP platform, but it can go to NS user defaults, shared preferences, or indexed DB when running on the web. So I'm going to be showing you a little bit of a demo to give you an idea of what I can do when taking an application that comes from Windows and going to the web. So I've created already an application using our Visual Studio add-in that you can find directly in the Visual Studio Marketplace. And what it creates you in is a sample application that has Android, iOS, a shared project that contains XAML files, UWP, and WebAssembly. So what I'm going to be doing is just using the standard tooling for UWP and start my application here. And I'm going to be adding some features to my application to make it a bit richer. To make it a bit richer. Oh, sorry about that. So what I'm going to be doing is just adding something very simple. So I can change the text here and do something else that can add to my application. So I'm going to be adding just a simple slider. And with that slider, I'm going to be binding that to the text block that's just up top. So I'm going to be adding a binding here to a property that's called value that's on my slider using the element name slider. So it's basically binding the text that's here. So when I slide it, it just updates my UI, and I can see the value of the slider. So when I'm done doing this, I can just go to my WebAssembly application, set it as a starter project, run it directly, and then my application is going to happen to go directly on the web inside of my browser, and I can just test it away. So it's loading up, and then you can see that I have the same thing that's running there. So basically, I've done my application on Windows and just ported it over to the web. It goes the same way for iOS and Android, but the interesting part is really WebAssembly there. So the demo in itself is very interesting because you can do more things with that. And by more things, we're talking about what we call the Uno playground. And that's an application that allows to see what we can do. That application is completely running locally on my machine. And it's doing things like, let's say, for instance, a view box. It's something that allows to do things like manipulation of when you have a responsive application, you can shrink content very easily. Or you can have data binding that you can test right away. For instance, this is a combo box that I have here that's data bound. The text of the combo box is data bound to the text that's underneath. So when I change it here, it becomes something else. And the interesting part is that the window that's here is JSON, and that JSON is parsed using JSON.NET. And there's nothing that we have changed to make it run on the web. I mean, we've taken the package that comes from James and put it in the application, use it directly inside of the browser. And in itself is quite amazing. So that whole application that is using .NET and WebAssembly, nothing goes out. It just works right away. And there are a few other things I encourage you to go look at the applications that like, for instance, images with fillings and things. So that's one of the very interesting parts. Another part that's interesting, and that one, when we got it to work, I mean, too many things at once. This application is very special because it's on the side. So on the left side, you're going to see C# code. That C# code is going to be compiled into in-memory assembly, so inside of the browser using Roslyn. The code that's inside uses Entity Framework Core to manipulate a database that's inside of the browser as well, that's using SQLite. So when I press execute, Roslyn's going to kick in, compile that code, search for the class that's called sample class, that's here, search for the run method, that's here as well, and execute that method inside of the browser to add a new line and iterate all the lines that are inside of the database. So it's kind of a tech soup, that I call it. Because there's, you won't find a kind of mix inside of an application, but it's to give you an idea of, we're talking about Roslyn, the gigantic piece of code that is compiling C#, and it's running inside of the browser. And to give you an idea of that, it's actually the compiler there. I'm going to make a typo, and it fails. So it's really the compiler here. It's going to say to me that I forgot about a comma or something. So semicolon. So it gives you an idea of the sense of what WebAssembly is able to do. You can take very large pieces of code. They're very complex. I mean, Roslyn is using immutable structures everywhere, hammering the memory. It's doing very funky things, and it's still working. Entity Framework is the same. I mean, we've taken the NuGet package that is provided by Microsoft from the NuGet.org, added it to the application, it runs without any modification. So you can push it. That's what I mean. You can push it really hard. And if you have .NET Standard 2 applications or libraries that you have already, that means that you can run them inside of the browser. So if they're doing funky things like doing image manipulations or things like that, that works. That will work, most probably. So it's getting very interesting to see what that's going to do. So one thing that's to note here is that that application is running inside of WebAssembly, but it's still running using a single thread because it's still a JavaScript context, and the threading is not here. So that means that when I press execute, if it takes a minute to build, it will freeze for a minute. So just so you know. Threading is going to come later on. It's actually enabled by default now in Chrome and the new Edge dev, but that means that we're going to have an upgrade of Mono to be able to use threading. But it's going to come, which is very interesting. So that's to give you an idea of the samples that we can have using WebAssembly and .NET. So lessons learned. And I mean, lots of things have been happening since the beginning of Mono and WebAssembly. But the most important part of it is that the execution of the .NET code has an exact fidelity. I mean, down to how the GC handles work for weak references. That's something that's very difficult to get right. And people have been trying to emulate .NET using other technologies, and it's not the same. Here we're talking things that do exactly the same that you can find on Linux or on Windows. It's the same. So that means that it has the potential, if the other things that I'm listing here are fixed, then it has the potential to do way more than that. And for what it's worth, I think it will replace or help a lot in terms of getting applications that run on desktop directly or that run on the command line, for instance, and make the universal binaries that we've been searching for all those years. So the other problems are the fact that AOT is still very large. That one has a very big impact. I mean, we're talking about, for an application that could be very large, like 40 megabytes or something, having broadly compression helps, but it's still very large. So that means that if you want to do a website that, let's say you want to make the New York Times homepage with that, it may take you a while to get there. So that's not the case. What is a good, we think is a good target for that is, business applications, for instance, or applications that you may want to pay the price once, like, for instance, Gmail, for instance. If it loads a bit longer the first time, that's fine. And for the other times it loads up instantly, that's fine. That's what we're talking about. So if the application is large, it doesn't matter that much, but it matters for the first load. But afterwards, the browser is going to cache everything, and it's going to run fast. It still relies on Emscripten, and Emscripten, let's say it's a very good experiment, but there's quite a few things there that need a bit of love. So it's going to improve, and with WASI, it's going to help a lot. For the performance, if you're doing AOT, no stack trace. So that means that when you have an exception, you don't know where it comes from. So that's a bit of a problem. We're used to having our stack traces when there's an exception to debug. So that's the biggest of the problem. You can fall back to the interpreters who have the stack traces. That helps. But if you have a problem that only happens in AOT, it's difficult. And you have other things like the try finally blocks that can be slow because of the way Emscripten works. And because WebAssembly does not have any exception handling baked in. It's going to happen soon, but it's not there yet. So that means that Emscripten and Mono have to jump through hoops to actually do exception handling. So that's not nice for now. It works, but it's slow. And there's no managed provider to rely on for now. It's in Mono, but it's not easy to enable, not easy to get the file that gets out of it. So that's something to know about as well. So you need to rely on the provider from Chrome. It's still the web, so that means that CORS is still there. So if you used to do mobile applications where no limitations at all, well, you're going to face that. So if you're calling an API that is not CORS enabled, then it's going to fail. You can still use WebSockets very easily. Those don't have those restrictions, so that works pretty well. And interoperating with JavaScript can get very tricky. I mean, it's something that's, if you want to manipulate, it ends up, you end up creating code that looks like C, basically. Yeah, you manipulate the memory with indexes, allocating, using malloc and free and things like that. So it's not nice. It's plumbing code. It has to be there, but you have to deal with it for now. The future is going to be interesting as well. We're talking about garbage collection, which is going to enable the host binding support. So for now, when we want to access HTML, we have to go through JavaScript. But if we were to be doing it using a binary interface, then that means that we would get pointers from the browser. So if you get pointers from the browser, we need to do some kind of things like memory pinning or memory management or freeing the pointers that we're given. So things like that. But things like OpenGL are opening up for that. In Chrome, they're starting to do experiments about being able to call OpenGL, WebGL directly from WebAssembly without going through JavaScript. And it's getting some very nice performance improvements. So in the end, it's going to be many other APIs that are provided by the W3C that are going to be enabled there. CMD is another one. CMD threading. So it's about performance, threading, multiple threads. So there's a caveat there for performance. For threading, the idea is that you have to know in advance for now the number of threads that you're going to use. It's kind of clunky in a way, but it's better than nothing. So if you try to do that with Unscripted, that's the kind of things that you're going to face. CMD is about vectorization, so very high performance code, things like libraries that do image manipulation, video manipulation, encoding, and things like that are going to benefit a lot from that. And exception handling, of course, that one is something that we're going to benefit a lot in terms of performance. To give you an idea, in Uno, we've removed some of the using that we've added there for clarity of the code just to make it faster for now. So it's a bit less secure in terms of a little bit less sane in a way, or safe, and then it executes faster, but we're going to enable it back when exception handling comes up. I'm going to give you a bit of links that you can go through to see what this is all about. Please have fun with it. The Uno Bootstrapper is open and free to use. Same thing with Uno. Let's say it opens up lots of opportunities to get applications running in the web, and your code that you've been writing for a long time may run there as well, so please give it a try. Thank you.